Hi everyone, welcome back to our channel. So Shomu sir, what are we discussing today?
Another beautiful geometry-based time and distance problem, very similar to, not similar to, but geometrical idea would be prevalent as was in the previous video that we did. I mean, the question in the previous video that we did. So let me not waste time. First of all, let's get into the question first. We have two ships approaching a port. So two ships, both are approaching a port. So they're approaching the same port along straight routes at constant speed. So it doesn't say the same route, right? It just says along straight routes at constant speeds. Initially, the two ships and the port formed an equilateral triangle. Half of the people will give up at this point, but don't. So think, so whenever you are talking about three objects forming an equilateral triangle, what does that mean? So it's basically that these three objects should be vertices of that equilateral triangle. That is how they would form an equilateral triangle, isn't it?
Correct.
So the port and the two ships, wherever they are, if you consider them as 3 points and connect them by straight lines, you'll form an equilateral triangle. I hope that you can visualize this mentally now. So something of equilateral triangle will form. And the side of that equilateral triangle is also given to us, where we'll come back to that. When the slower ship traveled 8 kilometers, the triangle formed by the new position of the two ships and the port became right angled. So now the vertices, the port has not changed. I mean, the position of the port has not changed, right? It is where it was earlier. Just the ships must have moved closer to the port, right? So we have that straight line connecting the ship to the respective ship to the port. So they are traveling in that direction along the sides of the equilateral triangle. But after the slower one has traveled 8 kilometers, the positions of the two ships and the port make a right angled triangle, right? Something like that. Now, one thing straight away, I mean, this is intuitive, but you should pay attention to that intuition. One thing that is intuitive is when the slower ship has traveled 8 kilometers, the faster ship must have traveled more than 8 kilometers, because the question is saying it is a slower ship, right? Which has traveled 8 kilometers. So the faster will obviously travel more, isn't it? And we are looking for when the faster ship reaches the port, the distance in kilometer between the other ship and the port. Fair enough. So we'll come back to that. So what happens when the faster ship reaches the port or something? So we'll come back to that. So let me just first draw this, draw a big triangle rather. So let's say this is the equilateral triangle to begin with. I don't need to draw this base, but I'm just drawing it. So suppose this is the port, and this is the slower ship, and this is the faster ship or something. I can take either ways, it really doesn't make any difference. So initially it's an equilateral triangle, right? And if it's an equilateral triangle, all of these angles are 60 degrees. Now, the slower ship is moving toward the port. So this ship is traveling along this side, and this is traveling along this side, right? The next line from here, it said that when the slower ship traveled 8 kilometers, also let me mark this 24 kilometers. Just keep in mind that this is equilateral. So I'm just marking this 24 kilometers here. I'm not writing kilometers, everything is in kilometers. So when we have 24 here, so obviously the other two also have to be 24. So when the slower ship traveled 8 kilometers, so let's say reach this point. So this is 8 kilometers, this much. The three things, I mean, the port and the two ships make a right angle. So basically it's a right angle triangle now, right? Now, remember the faster ship must have traveled more than 8 kilometers. So it should be somewhere here, right? Now, which of these can be 90 degrees if you think about it? So this is 60 degrees, right?
Okay.
A basic idea of any triangle, opposite to the smallest angle will be the shortest side, opposite to the largest angle will be the longest side, right?
Correct.
So if I think about it, I mean, you cannot have 90 degree here, because opposite to 90 degree, whatever is here, that will be less than this 16, right? I mean, this is 16, isn't it?
Right.
So the slower ship must have traveled less, so the remaining distance should be more, isn't it? And the faster ship should have traveled more, so the distance to the port should be less, something like that. So opposite to 90 cannot be a side which is less than opposite to another angle, isn't it? So the 90 degree must be here, because this cannot be 90 degree, right? This is 60 degree already. We know that. So basically, if I just assume this to be 90 degree here, because the question says so. So now we have a triangle, a small triangle out here, which is a 30, 60, 90 triangle.
Correct.
So in a 30, 60, 90 triangle, this is something we have also discussed in our lessons. By the end of the video, I'll just give a small brief. It's very easy actually. In a 30, 60, 90 triangle, the sides are in the ratio 1:√3:2. 1 opposite to 30, √3 opposite to 60, and 90 opposite to 2. So if you remember this, you don't have to use sine 30, cos 60, and those kind of stuff, tan 30 and 7. You can if you know about it, but those values are determined from this ratio only. So you have 30 degree here, 60 degree here, 90 degree here, right? Which is known to us. This 16 is opposite to 90 degree.
Right.
Now, what is the concern here? What is the context of the, or rather the objective of the question? When the faster ship reaches the port, the distance between the other ship and the port. So basically, to this point, how much has the faster ship traveled? That is something we have to figure out, right? And that is this distance. So this is our main concern out here. What is this? Something like that, right? And we know this entire thing is 24 kilometers. So if I can figure out this one, then I can figure out this one.
Right.
And in this triangle, this length or this side is opposite to 30 degree, right?
Okay. Correct.
And 30 opposite to them are in the ratio 2:1, right? I mean, 90 is 2, 30 is 1. So basically, whatever is opposite to 30 degree should be half of whatever is opposite to 90 degree, isn't it?
Right.
So 90 degree opposite, we have 16. So opposite to 30 degree, we should have 8.
Right.
And if this is 8, the total is 24. So this thing should be 16.
Right.
So now what do we know? We know that when the faster ship travels 16 kilometers, the slower one travels 8 kilometers.
Right.
Isn't it? So both of this happened in the same time, right? So faster ship traveled 16 kilometers and the slower one traveled 8 kilometers. So by the time this happens, this happens in the same time, and we are looking for when the faster ship reaches the port. So what is the remaining distance for the faster ship? That is 8 kilometers.
8 kilometers. Right.
So when the faster ship travels the remaining 8 kilometers, see, this is half, right? So the slower ship should travel half of 8, that is 4 kilometers. So what will the slower ship travel in total? That will be 12 kilometers from this point.
Right.
And this entirety was 24 kilometers. So the remaining distance, so we are looking for the distance between the other ship and the port, right? So the remaining distance will be 24 minus 12, which is again 12
kilometers. Nice.
Yeah.
This was interesting.
Nice problem, as I said. I mean, geometry based and 30, 60, 90, if you are aware of it, you should be aware of it. Otherwise, you would find it difficult to solve this. Either you should be aware of what is this? Tan 30, either you should be aware of that. Or you should be aware of, no, not tan 30, my bad. Either you should be aware of sine 30 or you should be aware of this 30, 60, 90. Either one will work, but then 30, 60, 90 is always easier. Let me just take a minute to explain why this 30, 60, 90 thing happens. It's very easy actually. So if I just start with an equilateral triangle. Equilateral triangle is 60 degree, 60 degree, 60 degree everywhere, right? Now, if I draw a perpendicular, this is 90 degree, this is 60 degree, then this will be 30 degree, right? So I'm marking the 60 degree with double line and 30 degree with single line. Easy to identify here. So see, if I have an equilateral triangle, suppose the side length of equilateral triangle is 2.
Okay.
Then if I drop a perpendicular, then that will obviously bisect the side because it's an equilateral triangle, right? I mean, you can prove by congruency also. I mean, this half will be equal to this half. So this will be 1, right? If this is 2 and this is 1, then the height you can calculate √2 square minus 1 square. So that is √3.
Okay.
So that is the ratio you obtain, right? Opposite to 30, 1. Opposite to 92. Opposite to 60, √3.
Okay.
So basically a 30, 60, 90 degree, a 30, 60, 90 triangle is nothing but half of an equilateral triangle. That's the idea. I mean, even the thing that you obtain, I mean, for an equilateral triangle, the height of equilateral triangle is √3 by 2a. So that's the same idea, right? I mean, if this is a, this will be 3 by 2a, right?
Right.
The same idea, just represented in different ways. Yeah, so that's it for this problem.
Thank you, sir. Thank you so much for this question.
Yeah, thank you, Asha. Thank you, everyone. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.